Hello, ladies and gentlemen. Today we're going to be solving exponential equations with common bases. Remember, exponential equations are functions or equations with x in the exponent. So far with exponential functions, we've graphed them, we've written the functions according to the graphs of them, and now today we're going to solve them. So what you're going to need is your notebooks, a writing utensil, your roots chart, so that little chart that has all your perfect roots on it, like your perfect squares, your perfect cubes, your perfect fourths, your perfect fifths, and probably a calculator. As always, let's start this video by reviewing and not necessarily writing it down in our notes. So if I were to ask you to rewrite each pair of numbers so that they have a common base, 8 and 32, we have to think about, by looking at our perfect roots chart, 8 and 32 are both perfect, or they both have a common base of 2, where 8 is a perfect cube and 32 is a perfect fifth. But they all could have the same base of 2, where 8 is just 2 raised to the third power and 32 is just 2 raised to the fifth power. So if we look at another example with the same set of directions, if we rewrite each pair of numbers so that they have a common base, if we have 3 and 81, we can rewrite 81 as 3 to the fourth, because 3 can't be any more simple, it's just 3 to the first. So they both have a common base number of 3. And let's look at another example, getting used to that perfect roots chart and looking up numbers. So if we rewrite each pair of numbers so that they have a common base, 25 and 125, well, we can rewrite 25 as 5 squared, and we can rewrite 125 as 5 cubed, so they have a common base of 5. So you didn't have to write any of these examples down necessarily in your notes, but this kind of thinking and processing is what we're going to need today in order to solve the problems. Okay, let's try one more just for good measure. What about 1/7 and 49? Well, 1/7 can be rewritten as 7 to the negative 1, and 49 can be rewritten as 7 squared. So we can even make numbers with the common base, even if we have fractions and numbers that aren't fractions, okay? All right, so now you can start writing in your notes, in your foldable, the method of common bases. If you see a variable in the exponent, you need to get the bases the same if possible, and then set the exponents equal to each other. So that's what we're going to do for all the problems that we're going to solve today. We're going to break it up into 2 steps. We're going to make sure we get both of them written so that they have a common base, and then set the exponents equal to each other. Okay, so example number 1. We have 5 to the x is equal to 5 to the fourth. So remember the 2 steps, we need to get the same bases. Well, 5 and 5 are the same base already. And now all we have to do is set the exponents, like x and 4, equal to each other. Well, there's nothing left for me to do to solve. So in this example, x is equal to 4. Okay, example number 2. So we have 4 raised to the x power. So we need to rewrite 4 and 8 with a common base of and 4 we know can be rewritten as 2 squared. That's all getting raised to the x, and that's equal to 8 can be rewritten as 2 cubed. So remember, when we have a power raised to a power, that's just like multiplying the exponents. So now we have an equation where we have the same base. So now all we have to do is set the exponents equal to each other. So we have 2x is equal to 3, divide by 2, and x is 3/2. All right, example number 3. We have 3 to the x plus 1 is equal to 9 to the x. So I need to get 9 into a common base of 3. Well, I know 3 squared is the same thing as 9. And if we raise a power to a power, we end up multiplying. So I have 3 to the x plus 2 is equal to 3 to the 2x. So now I can just set x plus 2 equal to 2x. So if I minus x on both sides, I'm left with 2 is equal to 2 minus 1 is 1x. So that's my final answer for that one. All right, example number 4. So now I have 81 is to the x plus 2 is equal to 27 to the 5x plus 4. So I need to find a common base for 81 and 27. So I have to rewrite them with a common base. And I know that 81 is the same thing as 3 to the 4th, and that's going to get multiplied by the exponent that it has, which is x plus 2. And that's going to be equal to 27 can be written as 3 to the 3rd. And that's going to get multiplied to the 5x plus 4. Okay, so now that I have them as a common base, I can just set this equal to this. So I get, whoops, sorry about that. I get 4 times x plus 2 is equal to 3 times 5x plus 4. So before I simplify, before I get x on one side, I have to distribute both things. So 4 times x is 4x, and 4 times 2 is 8. 3 times 5x is 15x, and 3 times 4 is 12. Now I can subtract 4 from both sides. And then I'm left with 8 is equal to 15 minus 4 is 11x plus 12 minus 12 on both sides to get x alone. I'm left with a negative 4 is equal to 11x. And then my last step is to divide by 11. So I have a gross number, which is x is equal to negative 4 divided by 11. So that's my final answer for number 4. Example number 5. Okay, now this one looks a little different. We have 9 to the 2x plus 1, all minus 2 is equal to 25. So I need to isolate this guy completely on its own. So I'm going to add 2 to both sides. So now I have 9 to the 2x plus 1 is equal to 25 plus 2 is 27. So I have to rewrite 9 and 27 as a same base. Well, they both have a common base of 3, where 9 can be rewritten as 3 squared, which is going to get multiplied by that 2x plus 1. And 3, just like the last one, can be rewritten as 3 cubed. So now I can set this equal to 3. So I have 2 times 2x plus 1 in parentheses is equal to 3. So 2 times 2x is 4x. 2 times 1 is plus 2 equal to 3. Subtract 2 from both sides. You get 4x is equal to 1. And then divide by 4 on both sides, leaving you with x is equal to 1/4. And our last problem for today. So we have 7 to the x minus 1 is equal to 1 over 343. So if you think back to the beginning of our video, we could rewrite 1 over 343 as 7 to the negative 3. And then we have 7 to the x minus 1. So now I can set x minus 1 equal to negative 3. And then add 1 to get x alone. And we're left with x is equal to negative 2. And that is all that I have for you guys. So I want to thank you for taking good notes. Make sure you get this in your foldable and you star any questions that you may have along while you've been following along in this video. And then when we come back, we'll do some practice problems on a worksheet. So I'll see you soon.